Hello guys. Hello everybody. Hello everybody. Let's go back to solving problems. Okay. At this time class, we're going to solve uh, properties of gases. Okay. This is specifically gas stoichiometry problems. Okay. This is still under physical chemistry or related to thermodynamics. Yes, but this is more on stoichiometric relationships calculation of the properties of gases. Okay, I will drink water so that I have energy to discuss. But before solving gas stoichiometry problems, you must remember the different theories, concepts, and principles, and a lot of formulas regarding ideal gas law and an ideal gas law. And we need to present formulas and equations. If you want to learn something, then you can get a blank sheet of paper also, and you can write the formulas. Actually, these formulas also are being discussed in our high school, okay, chemistry. Okay, and then then first year college, second year college, third year college. It will keep on repeating again. This this behavior of gases. Okay? Okay, we need to introduce the formula now. So our timer starts now. One, two, three. Okay, first equation. Okay, PV and RT, ideal gas. Pressure constant times the capital T in temperature, normally expressed in degrees Celsius. Okay, there's a difference. Okay, usually the attack of any problems if they put them in degrees Celsius and you have to add 273.15. Okay, so that it will become temperature units. Okay, and the one I told you before of formulas of temperature, so formulas here. Pressure, the absolute pressure, okay, the vacuum pressure, okay, that of times for gas accumulating problems. And here also you have to recall the Avogadro law. Okay, Avogadro law that states that the amount of gas is directly proportional to the volume of gas occupied by an ideal gas. Okay, so meaning to say if we have two gases in one mixture reacting with each other in a container, so it's gonna be V2 volume 2 over the number of moles 2 is equals to the volume 1 over the number of moles 1. Okay, 1 and 2 are simply the independent gases in that particular mixture inside the container. So that is Avogadro law. Okay? But sometimes the Avogadro law can be obtained by ratio and proportion only, especially if you have the stoichiometric relationship in terms of number of moles in your equation after you balance the chemical reaction. Okay? Because normally one volume will be given, something like that. Okay, that's Avogadro law, don't forget for that. And then, number 2 na yan ha, within RT, Avogadro. Number 3 is the Dalton's law of pressure that states that total pressure in a mixture is equal to the partial pressure of each gas in a particular mixture. So, for example, if there are a lot of gases there, it could be uh, partial pressure of gas 1 plus partial pressure. Dalton's law of partial pressure. Okay? And take note also, you have to compute for that mole fraction of each in that particular mixture, which is also equal x a partial pressure and the total pressure. Okay, so we have now partial pressure of a component is equal to the mole fraction of a component times the total pressure of the mixture. And then Baden again, okay, mole fraction. Okay, it's gonna be like that. Okay, partial pressure of B component is equals the mole fraction of B component times the total pressure of the mixture. None. Okay? We are just reviewing because I discussed this a while ago, man, in the last 2 weeks in the previous vlogging and live stream. I don't have to right now. Just put that in your brain cells. Okay? Guys, if you listening with my vlogs and streaming, live streamings, then you can put that sheet of paper, memorize, and inject in your brain cells. Okay? So that every time I will do the live stream, it will automatically go directly to save time. Wow. Ganon. Okay? So that's ideal gas law, Delta's law, pressure pressure, Avogadro law. And then the Avogadro law plus, it should obey STP, standard temperature and pressure. When you mean standard temperature here, 0 degrees Celsius, okay, 273.15 Kelvin, and 32 degrees Fahrenheit, okay, and 1 atmosphere pressure. Okay, meaning to say, simply the melting point and the freezing point of water, because that is 0 degrees Celsius, right? Okay, 32 degrees Fahrenheit and 273.15 Kelvin. So it's gonna be like an STP. So the one mole of an ideal gas will occupy 22.414 liter, okay, in a space, in a volume space. Ganon. Okay, that is also our basis to get the molecular weight of, or the molar mass of air. The basis is an ideal gas magud siya, or ideal air that is 1.20 density, 1.29 kilogram cubic per meter. Density of air. Okay? Like, and the molecular weight is very easy. You have to get the individual molar mass, add that to the nitrogen and oxygen specifically. Yeah, if you speak, okay, then you add that one and get the density. Okay, the volume can be obtained through the one mole of ideal gas by ideal air will occupy 22.414. So you have now the volume, then bingo, you can solve for the density. Density mass over volume. Okay, because you can solve also the molar mass through the molecular weight. Ganon. Okay? So you can compute the density for that. Number 4, what else? Okay, we have number 4, we have the Henry's law. Henry's law. In Henry's law class, it talks about the concentration and solubility. Okay? Okay, P2 over P1 equals to S2 over S1 and S is simply the solubility of the concentrations. Okay? Expressed normally in most parameters. Okay, something like that. And then for the individual computation of the pressure of the solution, it will be equal to the Henry's constant or solubility constant, okay, times the partial pressure, okay, of the solvent. Solvent siya ha, remember, okay. Okay, partial pressure of the solution, iba kay Dalton's law, di ba? Okay, kay Henry, partial pressure of the solution is equals to the mole fraction of the solvent. Okay, times the total pressure. Okay, like that. Okay, so it's gonna be like that. So that's Henry's law. Okay, what else? For na siya. Okay, four or five. Let's see, four na lang siya. Number 5, the combined gas law. Okay, P1 V1 over N1 T1 is equals to P2 V2 over N2 T2. Okay, that's a combined gas law. Meaning we combine all the 3 laws of ideal gas, so that Gay-Lussac's law, the Charles law, and the Boyle's law. Okay, 5. Then Boyle's law, P1 V1 is equals to P2 V2. Okay, Gay-Lussac's law, P1 over T1 is equals to P2 over T2. Charles law, V1 over T1 is equals to V2 over T2. 8 formulas. The ideal gas is equal to the square of 3 times universal gas constant over the molar mass. 10. Then formulas na ha, sa ideal gas na siya. Okay, 10. What else? You have to compute for the okay? Equation number 11. Compressibility factor. Compressibility factor is very important, guys, because this is to determine whether our gas is a real gas, an ideal gas, or an ideal versus ideal gas. Okay? If our Z is very small, it's gonna be a real gas. Or a bag is gonna be ideal gas. Something like that. Or is it equal to 1 is ideal gas? Just review that also, maybe I forgot. The Z factor is very important as in your indicator. Okay, if it is a real gas or ideal gas. Okay, Z is equals to the pressure and the molar volume over universal gas constant times T. 11 equations already. And we have also the number 12 equations. What else? Van der Waals equations for real gases. Equation number 12. Okay, what is this? Pressure is equals to the nRT over, okay, B minus NB minus A S squared B squared. Wherein A and B are the constants. A is the constant that describes the strength of the gas particle. Okay. B is a constant that describes that and B are correction factors. A is the correction factors in terms of intermolecular forces. Okay, and B is the correction factor in terms of the molecular volume that the gas particle occupied. These are the constants of the Van der Waals equation of real gas. Okay, like that. This is number 12 equations. What else? We still have the virial coefficient for an ideal gas. What is that? Virial coefficient. Z is equals to 1 plus B apostrophe times P. This is also the Z. Equivalent to the kinetic molecular fluid that have Z also, right? The Z there in ideal gas law is Z is equals to P, the molar volume over RT. In here, in the real gas, in the Van der Waals equation, we have Z is equals to 1 plus B apostrophe B, wherein B apostrophe is the virial coefficient of the real gases. Okay? That's B. And then we have also to compute the A and B. If A and B are not given in the problem, we need to compute. Okay? How to compute the A? The constant in terms the drive of the strength of the particle or the intermolecular forces. How can we compute? Okay. A is equals to the molar volume or the critical volume over 3. Okay. And the B is equal to critical pressure. Okay, critical pressure na because critical volume na dito sa A. Okay, mo na siya. So, the equations of Van der Waals. Okay, but there's also the molar volume for the Van der Waals. It's very easy. Okay, pressure is equals to R times T over Vm minus B. Yung ganun siya, okay? Minus, okay, the B, sorry, the A over Vm over just about 2. Okay, ganun siya. You have to memorize na lang okay, para hindi mo maglibog ha. Okay? Ganun na talaga siya. Okay? Again, RT over Vm minus B minus the A over Vm raised to the power 2. Vm is the molar volume. What is the molar volume? Molar volume is equals to the regular volume over the number of moles. Just like molar mass is equals to the regular mass over the number of moles. Okay, like that. Okay, something like that. Malong, but in terms of the compound, the molar mass will be equal to the molecular weight. Okay, something like that. So there are 13 or 14 equations already that will be used in the computation of the properties of gases in gas stoichiometry problems. Okay, then we're ready now to solve problems. For that, or not share? Now, tell me. Okay, now if we go also to the mole fraction, very easy. Mole fraction of one component over mole fraction, total mole fraction, something like that. Okay, if we speak of mole, of course, mole fraction. If we speak of mass fraction, that is mass also. If we speak of volume fraction, that is also volume. If we speak of pressure, that is also pressure. Because sometimes pressure fraction, volume fraction, and mole fraction. But the principle is just the same. Okay? Like okay, you have to the numerator will be the individual component and the numerator and the total component of the gas. Okay? So we need now the problems for this. Okay. Ready na tayo. Okay? Okay, class. Okay. Guys, the chemical engineering board examination will be on October 2021. Okay. So you can listen to this because it will come out within the board examination. Okay. Number one. Okay. Solid magnesium nitride, okay, reacts with excess liquid water to produce ammonia gas. Was collected at 300 Kelvin at a pressure of 1.6 atmosphere. How many grams of magnesium nitride was consumed in the reaction? This is Chemical Board Examination, November 1993. Okay. The choices would be A, 14.4 grams, B, 15.17 grams, C, 12 to 18 grams, D, 11 to 14 grams, and E, none of the above. Okay, this is question number one. Question number two, this is Chemical Engineering Board Examination 2004. Okay, I compiled the previous Chemical Engineering Board exam. Okay, number two, 4.85 liters of ammonia gas at 27 degrees Celsius at 1.45 atmosphere was mixed with 5.23 liters of oxygen gas at 32 degrees Celsius at 1.63 atmosphere to produce at 1.63 atmosphere to produce water and nitrogen gas. Lakoy, tararat tayo. To determine the volume of nitrogen gas produced if it was isolated and collected at 37 Celsius at a pressure of 1.22. Not to be honest, a little bit difficult. Okay? A little bit difficult lang ha. Pagili siyang difficult. Okay? But the way that the problem presented is difficult, right? See? Okay? But when you solve this, this is not really very difficult, only a little difficult. Okay? But not easy. This is not really easy because it requires a lot of, finding the ease. This is not directly substitution kasi. Okay? And this is not problem number two. So these two are chemical board examinations in different years, 1993 and 2004 respectively. Ano ba ito? Okay. Both November. Okay, because the board examination of chemical engineering scheduled in November and May. Right? Am I correct? But now they changed October because of pandemic issues. Okay, something like that. They changed the schedule. Okay, these are the problems. How can we do? How can we attack to solve these problems? Oh my gosh! Question number one lang sa attack. Question number one. Kung sa kong papel, I have to solve. Oh my gosh. Ito battery. Galingan ako niyan. Ako mag-microphone because raw battery. Okay? I have to make my voice very loud. Okay. Question number one. Actually, it's a little bit of chemical calculation. Mix also with chemical calculation. Okay. Okay, given. Number one. Solid magnesium nitride. What's the formula? Guys, this is what I told you. Okay? This is what I told you. The chemicals are written in a statement, not in the molecular formula. So you have to think what is really the symbol for this or element for this. Okay, what is magnesium nitride? Normally, you will be confused. We have also fluoride, chloride, sulfide, like that, right? And nitride. Remember, this IDE class will change, will vary. Chlorine, -1. Remember that one, okay? Sulfide, -2. How about this nitride? This is -3. Okay, so magnesium, what is the charge of magnesium? We do like this. It's not presented in the problem. It's not given in a molecular formula, magod siya. Okay, so magnesium nitride. So how can we do this? Magnesium is positive 2, right? So we need to, buy the, what do you call this one? This is, what kind of bonding is this? I forgot. This is, oh my gosh, ionic bonding. Okay, ionic bonding. This is not polar covalent, but it's ionic bonding. Okay, ionic bonding, because nitrogen is a sort of negative and magnesium is a sort of passive, and the neutralization reaction between the ions, right? This is ionic bonding. Okay, there's no hydrogen, so this is not hydrogen bonding, and the electrons aren't being shared completely, so this is not covalent bonding, right? So this is more or less ionic bonding. Okay, so we need to, to replace their charges, transposing their charges, so that these two elements, magnesium and nitride, will neutralize with each other. Okay, ganon. So it's gonna be magnesium. Okay, like this. So, okay, this will become now Mg3N2. Okay, now solid magnesium with excess liquid water. So solid meaning S. Okay, small letter S. Every time in the reaction you have to put like that, especially stoichiometric relationship, because there are amounts to solve. Okay, it's very important to put the individual phase, solid, liquid, and gas, somewhere along your chemical reaction. Okay, and then with excess liquid water meaning H2O, okay, plus H2OL, right? Okay, ganon. Take note, H2OL, and your product will be to produce. To produce meaning produce. There's a product, ammonia gas. Oh my gosh, ammonia gas. Okay, ammonia gas, meaning to say NH3, right? Ammonia gas was collected at 300 Kelvin at a pressure of 1.6 atmosphere. How many grams of magnesium nitride was consumed in the reaction? Lawe. Gas. Class, look at the problem. It's given only the one product, which is ammonia, and we will be the one to produce other product. Because class, this is a hydrolysis reaction. Hydrolysis, okay, meaning the reaction of water. Okay, reaction of water produce gas. Okay, like that. Or aside from hydrolysis reaction, this is also double displacement reaction. If we add water in a chemical reaction, automatic hydrolysis, magod siya. Okay, then we can also have this as double displacement reaction. Okay, so NH3 plus, okay, magnesium hydroxide, right? And then hydroxide class is -1 charge. Okay, like that. So magnesium hydroxide. So -1 like this, and +2 magnesium, so it will become like this. Close and open parenthesis. You apply the close and open parenthesis class if two elements involved, such as OH, like that. Okay? Close and open parenthesis and button subscript. And then we need to balance the chemical reaction. First step. Okay, ganun siya, chuba-chucho. Okay, we should be careful, and we will not go to the basic requirement, which is the law of conservation of mass, right? The total of number of atoms of the reactant is equal to the total number of atoms in the product, and we need to use the algebraic expression to solve for the value of X, which we let that as the number of atoms individually in the reactant in the product. I am using now the direct way of putting the moles to save time. Anyway, I discussed already how to compute that one. But I told you guys that if you use that attack using algebraic expression, then your balance equation will be perfect. Okay, but if you just keep on trial and error method, starting from 1, what you're gonna multiply so that it will be equal to the product, and then change again to 2 so that it will be equal again to the product, and then badin, ganon. Okay, so there's a time that it will become wrong. Okay, because of too much trial error method you use. Okay, but for the other method is algebraic expression, letting x as the amount of number of moles of each product is very tasky, but your answers will be close to reality and perfect, something like that. Okay, that's my convenience. I don't want you to follow me. That's only my subjective opinion, because I found it easy to do that rather than trial and error method. For example, magnesium 3, oh, there's 3, I will put the 3 automatic. So because it's not really, for me, it is not really logical to do that, okay? The students also will be confused. But in here, I will use that. I will apply that to make it fast. I have no choice because the problem is very long. Okay? So, Mg, magnesium first, balance. Oh, magnesium 3, ganun siya, chuba-chucho. Okay, we have to put magnesium also here. Ganon. Direct to the point na ko. Yan ako mo systematic way of balancing the equation. So, 3. Ganon. Then, nitrogen gas. Nitrogen gas is 2. Oh, ganon. You have to put 2 also here. Okay? Then, hydrogen. Hydrogen at the reactant is only 2, and the hydrogen and the other one is 6 plus 6 is 12. Okay, 12. Yes. Malom is 12. So balance. So we have to put 12. So 2 plus 6 plus 6, 12. So 12 divided by 2, 6. Right? So we have to put 6 here. Then the oxygen, take note if it's balanced, the oxygen. Okay. Oxygen balance, 6. And then again, balance it again. I make it direct, for the purpose of saving time. So, okay. Magnesium 3 at the left, magnesium 3 at the left. Okay, look at this. Okay. Hydrogen 12, and hydrogen also 12 on the other side, the product. And then we have also nitrogen 2 also balanced. So this is balanced chemical equation. If you have a wrong balanced chemical equation, imbalance, then your answer also will be wrong, because this is stoichiometry, gas stoichiometry, problems and properties of gases. Okay? Automatic, you will be wrong talaga siya, even though you will use the formula correct. Okay? Something like that. So, how can we do this? How many grams? Data, given. The given. Okay. Ganun siya. Chuba-chucho. Okay. So, wala siya volume. Okay. And there's mass. Okay. Volume. Okay. Water to produce ammonia was... Okay. Pressure. Pressure of ammonia is 1.6 atmosphere. I found it, something wrong, because see, the temperature and pressure, something wrong with, because if this is the case, there's no volume. It looks like this is not a good gas stoichiometric problem, something wrong. This volume is very important in the gas stoichiometric relationship. I found it missing. Okay, temperature. Maybe I forgot to write. I don't think so. 200 Kelvin. Oh my gosh, really? So solid magnesium reacts with oxygen, liquid, blah, 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 so and so. Oh. Ala, kaniha dyan. Something wrong with the volume. But let's try, okay? Pressure and temperature is given. Okay, it's here. Try until you die. Charot! Pressure, temperature, like that, okay? And then, okay, how many grams of magnesium nitrite? So magnesium nitrite, okay? So grams of magnesium nitrite. So you have to solve for that. This is our required, okay? This one, magnesium nitrite, okay? Like that. And this one, okay? This is our, we need to find, okay? And then, okay, the given are pressure and temperature. Actually, we need to use the ideal goods law formula, which is PV and RT. But I doubt there is no volume. How can I do this? Okay, so PV and RT, PV and RT, okay. And then there's a temperature, there's a pressure. Okay, we can solve for the number of moles, but there's no volume. I forgot, maybe I forgot really. Okay. Okay, let's try. Okay, because it's not good to solve without other quantities, right? And then we will be complicated somewhere along the way because you have already the grams of magnesium nitrite. And if you have the grams of magnesium nitrite, okay, then you can solve for the grams of the ammonia. Okay, in relationship to the magnesium nitrate, because you have the number of moles in the chemical reaction, then you can solve already the grams of magnesium nitrate as long as you have the number of moles of the ammonia, because ammonia also is our product here in the reaction. If you don't have the volume, then we cannot have the number of moles of ammonia. Correct? Okay, now if we try really to assume this as an ideal gas, so we need to have 22.414 liters. Now, okay, but that is for 1 mole of ammonia already. And then we need to find the number of moles. Okay, so it is not really compatible because ideal gas is the totality man siya of gas between nitrogen and oxygen, ganon. But in his ammonia man siya, so we cannot use the 22.41 for at STP. In the first place, the temperature is given as 300 Kelvin and 1.6 atmosphere. It's no longer an STP. So we cannot force that to use that in this PV and RT in ammonia. Am I correct? Or else there will be no given pressure here, and we will assume that this is a standard temperature and pressure, right? If that is the case, we revise the problem. We will say solid magnesium nitride reacts with excess liquid water to produce ammonia gas. Let's show how many grams of magnesium nitride was consumed in the reaction. Assume the reaction to be an ideal gas law. Oh, ganon. Assume. So, assume ideal gas law, occupy man ang 1 mole of ideal gas of 22.414 liters. So we can solve for the volume of the ammonia in terms of the ideal gas. Okay? But there's given a pressure and temperature. What's the purpose of pressure and temperature here? Okay, so it must have also volume. Okay. Sorry guys. Clerical error. I forgot to write the volume here. Okay? Talaga. Okay, because it will take time to solve and then we have lack of quantity. Okay, so let's go to number 2 na lang siya. Okay, I will go back to the questionnaire and then I'll trace out the volume. I think so there's volume for sure. Okay, really. Okay, ganun, yes. Number 2 na lang ta. Okay, 4.85 liters of ammonia gas at 27 degrees Celsius, okay, and at 1.45 atmosphere was mixed with 5.23 liter of oxygen gas at 32 degrees Celsius at 1.63 atmosphere to produce at 1.63 atmosphere to produce water and nitrogen gas. Determine the volume of N2 produced if it was isolated and collected at 37 degrees Celsius at a pressure of 1.52 atmosphere. Oh my goodness. Okay, all you have to do is to do this individually. Again, chemical reaction. Okay, so in the problem, it says that ammonia gas is mixed with oxygen gas. This is the problem because it doesn't give the chemical reaction. You have to do it. Okay, ammonia gas, ganun siya. Sorry talaga, guys. Excited na kayo pumusol sa number 1, but there's missing volume here. Okay? If you have now the reviewer, I forgot the source, then you can trace that here. This is Chemical Engineering Board exam, November 1993. You have that? You have a reviewer there? Then tell me the volume. Okay? And then we go now to the Chemical Engineering Board examination. Okay, 2004. November 2004. Okay? This number 2. Okay? So, ammonia gas. Ganon. Plus oxygen. Oxygen gas. Okay? And then it will produce water and nitrogen gas. Okay? Nitrogen gas. In your class, this is gas to gas. Normally, the water here will be no longer as a liquid. It's also a gas because it will vaporize, something like that in the atmosphere. Okay, this is gas also. As a steam or a vapor. Okay, not the liquid. Okay. This is what I told you, that gas plus gas is equals gas, not gas plus gas is equals to liquid, in which water will deviate to this theory. Okay, hydrogen gas plus oxygen gas is equals to water, and water is liquid. Okay, it will deviate to the theory of chemistry, the reaction of water molecule. So I told you over and over again. Okay, so I will balance this one. So nitrogen, direct balancing equation. Okay, 2. Okay, and then we have the hydrogen 6. Oh my goodness. So 6 also here. Hala. 3 oxygen and oxygen gas here. So we need to have 3 oxygen. Okay, so our oxygen here is 2. How can we obtain 2? Okay, so this is 2x is equals to 3. Then x is equals to 3 halves. Algebra. Okay, so 3 halves. Okay, now since this is 3 halves, fractional number of moles should be avoided in a chemical reaction. So multiply both sides by 2 to obtain a whole number in each coefficient element or compound or number of moles. Okay, when you multiply, both sides talaga siya. Okay, just like in polynomial rule in algebra also. Okay. So, for ammonia gas, okay, class? Okay. 3 moles of oxygen gas is equals to 6 moles of water plus 2 moles of N2 gas. When you read this one, class, you need to say 3 moles, 3 moles, 3 moles. Okay, because that is coefficient. You don't have to say 3 atoms of water. No, it's not 3 moles always, because moles are expressing on the coefficient of the compound or the atom element. Okay, so balance the number of atoms now. If it is balanced all, okay. Atoms, atoms must be balanced, not the number of moles. Take that in your brain cells. Okay, so for nitrogen, okay, for nitrogen, 12 atoms of hydrogen, 12 atoms of hydrogen, oxygen, 6 atoms in the right. So perfect. This is a balanced chemical reaction. Now we need to input other data. For ammonia, ammonia gas. Chararat. Ammonia gas occupied 4.85 liters. See, there's a volume. As I told you, volume is very important here, okay? So ammonia is equals to 4.85 liters. And then, what else? At 27 degrees Celsius. Oh my gosh. So this is Celsius, guys. We need to add 273.15 automatically because temperature is standard in Kelvin man gud siya. Okay, in this gases theory. Okay, especially in the PV and RT. Okay, 273.15 Kelvin. Okay, 27. Charara. Okay, 27. Oh my goodness. 27 plus 273.15, guys. This is 300.15 Kelvin na siya, okay? Comma. This is for ammonia first. And then we have 1.45 atmosphere, okay? Then later we will be investigating what specific formula to be used out of those 13 properties of gases equations, 14 formulas, okay, for gases alone. So 1.35 atm. Okay, ganun siya, chuba-chucho. And then oxygen gas. Oxygen gas, guys, is 5.23 liters. And then at 32 degrees Celsius. So 32, guys, plus 273.15, how much? I cannot do it directly, but others can do the mathematical ability by just, by their brain. I will just use the calculator. Okay. 305.15. And then the pressure, guys, will be 1.63 atmosphere. Okay? Oh gosh. And then determine the volume of nitrogen gas. In fairness, volume of nitrogen gas. This is to be solved. This is the problem we asked for. Okay? Isolated and collected at 37 degrees Celsius. Okay, so pila man ng 37 degrees Celsius class. So plus 273.15. Kuan gid ni siya mga something. Charot! 37 plus 273.15 is equals to 310.15 Kelvin. Okay. And then also a pressure of 1.52 atmosphere. Oh my gosh. We have so many data information. We are loaded with data information. Sometimes too much data normally will confuse also the students. And also less data information will also confuse the student because it leads us to think what are those data necessary or additional data to be inserted in a particular equation or formula. But here is the reverse. So many data, how can we apply this? And now you investigate all the gases formulas, right? So the more closer to this is the combined gas law, because it was mentioned the volume, the temperature, the pressure, almost complete. Okay? Almost complete. By the way, I have to discuss now. The properties of gases are temperature, pressure, volume, the number of moles, the density, like that. Okay? It's gonna be like that always, huh? Again, pressure, temperature, volume, the density, the mass. 5. Okay? Okay, it will keep on repeating in the problems. Okay, these 5 properties of gases. Okay, but here there are already 4: volume, okay, temperature, pressure, and the number of moles. Okay, so what is that? So normally we will tempted to use the combined gas law, right? Which is P1 V1 in1 T1 is equal to P2 V2 N2 T2. But look at the formula. Can we apply that here in the chemical reaction? The chemical reaction class is double displacement or replacement chemical reaction or a hydrolysis reaction. Take note, there are 2 reactants and 2 products. Okay, normally that combined gas law will be applied only if there is only 1 reactant and 2 products, or 2 reactants, 1 product. So you can put that reactant as your 1 and your product as your 2. That's why P1 V1 in 1 T1. But it's in here. If we try to designate, this is 1, 2, 3, 4. We cannot say P1, V1, T1 in 1 equal to P2, B2, and N2, T2, and also P3, P3, B4, and 3. There's no such like formula in the gas law. So we cannot use the combined gas law, even if the data are already perfect for the combined gas law to be used. Okay. Second assumption or formula to be used. This gonna be the more closer is the PV in RT. Okay, because in PV in RT class, there is a number of moles, but in calculating the volume, guys, number of moles is very important because this is directly proportional with each other. They're relating with each other according to the Avogadro law. Okay, remember the amount of gas is directly proportional to the volume of the gas occupied in the container. So this PV in RT is applicable because Avogadro law behaves ideal gas. And also, PV in RT is an ideal gas law equation. Then bingo, PV in RT will be used. Okay? Thank you so much for watching, Ma'am Grizel, Saudi OFW channel. Hello po. Oh, somebody watch. Hi po. Okay. Hi po, ma'am. I'm vlogging regarding properties of gases and gas stoichiometry problems for, in preparation for the examination, particularly the chemical engineering board examination, something like that. Okay. So we need to use the PV and RT. Okay. Like that's very clear, right? So PV and RT in ammonia, PV in RT oxygen, PV and RT in the nitrogen, na ganun siya. Okay? Okay, let's start now. This is very tasky, right? Okay. Very tiring, but you have to be patient. Okay. So PV in RT ammonia, primero. So ammonia gas. Okay. So PV and RT. So get the number of moles of ammonia. So N is equals to PV over RT. Okay? So this is for ammonia, ha? Ayaw sa inyo ilubog ng oxygen o ng nitrogen, ha? Ayaw ilubog. Ammonia first. Utang buot. Wow. Okay? Pressure. 1.45 atmosphere. Okay? Volume. 4.85 liters. Okay. Now for the universal gas constant R, what is the constant we will be able to use now? I told you guys to memorize 2, right? At least 2. Okay, there's a lot of units of universal gas constant. You can calculate that through assumption of the ideal gas. Again, using the formula P in RT, and then calculate for R, then you can have the constants, all kinds of units, assuming that 1 mole of an ideal gas will occupy 22.414 liter of a gas at standard temperature and pressure at STP. So meaning to say the ideal gas law is always like that so that we can compute for the value of R if you don't want to memorize. Now I advise you to memorize at least 2 units. Okay, at least 2. In physics, usually being used is the 8.3146 joules per mole Kelvin, and chemistry 0.08206 liter atmosphere mole Kelvin is usually used. Liter atmosphere is a very unique unit of energy. Okay, liter atmosphere, very unique unit of energy. Okay, not the same with others, the joules, the calorie, the the British thermal unit, ganon, diba? So this is very unique liter gas atmosphere. Okay, so we need to use 0 because our volume here also are all in liters. Okay, and our pressures also are all in atmospheres. Okay, that's the main point. Okay, 0.08206 liters atmosphere mole Kelvin. Oh my gosh. Not to be honest, not to be arrogant, I still memorized this 20 years ago. until now. Okay, my memorization works. Okay, 0.08206. Okay, times 300.15 Kelvin. Okay. But duha ra jud akong gi-memorize. Okay? Atmosphere, liter. O, gano'n na siya. So, moles na ang mulugwa. Okay? Basic math. Let's do the basic math here. Okay? Even the elementary student and a grade school level can compute this. Okay? 300.15 times 0.08206 is equals to 24.63. Okay. Oh my gosh. 24.63. And then 1.45 times 1.45 times 4.85 is equals to, oh my gosh, 7.0325. So moles of ammonia class is 7.0 325 divided by 24.63 is equals to 0.2855. Okay? 0.2855 moles of ammonia, or N, small letter N, NH3. Okay? There's a number of moles of ammonia. Oh my gosh. Zoom in. Now, we solve for the number of moles of oxygen gas. Okay? Oxygen gas, usa ganito, oxygen gas is the most abundant element in the planet Earth, right? Because it gives us inhalation process and respiration process. So without oxygen, we will die, all living organisms in the planet Earth. That's why it is the most abundant element in the planet Earth or in the universe. Okay? The most important of all is oxygen. Okay? Something like that. So, number of moles of oxygen. The same formula, PV and RT also. Okay? Like that. Oxygen ha. So, pressure sa oxygen, tanawan lang ninyo diri. Okay? And let's do the direct substitution. Okay. So, pressure is 1.63 atmosphere. Right? Right? Very clear, right? Okay. As you can notice also, class, the pressure is very low. Okay? So, this is an ideal gas law. Remember the theory. Okay, the pressure in ideal gas law is very low, but the temperature is high. But the real gases, using the van der Waals equation, the temperature is low, but the pressure is high. You need also to check the applicability because that formula will not be used. Okay, if it will deviate to the concept and theory in the first place, nagsayang-sayang lakas imong formula. Okay, dapat you should target, okay, if it is ideal or real gas. Here it's very clear, it's 1.63 atmosphere only. Okay, you get the point? Okay, so volume for oxygen. So we have 5.23 liters. And also, guys, the compressibility factor has Z, small letter Z. Okay, that would identify also if our gas is ideal gas or real gas or non-ideal gas. You need to troubleshoot the behavior of a gas first before finding the equation out of those 13 equations of properties of gases. Okay? Like that. Because it will be rumbled in the examination. 0.08206 liter atmosphere, right? Okay. I forgot also to stress, guys, that the 3 units are 3 pala siya. We have metric system, we have the English system, and we have also the SI system. Okay, 3. I forgot, I always discussed in my previous vlogging the metric and the English only, right? But there are 3, SI, metric, and English. Okay? If the question was say, enumerate the three types of conversion factor, your answer will be SI, metric, and English. If the examination is enumeration, okay, like that. Before in my college also, I memorized like that. Okay, enumeration, outline, like that. And then because I heard already that they said multiple choice is the board examination. So at least you are advanced. Okay, like that. So fill in the blanks, explanation, definition, is higher than multiple choice only. Okay, so if the exam will be multiple choice only, so you are now confident. Okay, because you are developing a more rigid type of examinations in your brain cells. You understand? Okay, not never mind the true or false. Sometimes also, which is true of the following statement for kinetic molecular theory? A, gas particles will behave. B, also will come out in the theory examination also. A lot of that also, which is not true in the statement. Which is false in the following statement. A and B, C, neither of A and B. Ganon, libugon juga sa question. Okay? But if you know the theories and concepts, sa tutuwaron pa na siya, you should not be confused. Something like that. Especially the relationships. That's the power of relationships memorization, ha? Sa tanang mga properties sa science. Okay? Not only for these gases, also for the liquids, for the solids, relationships through the formulas. You can direct proportional, inversely proportional. What will happen to this? It will increase. Ganun siya. If you that really have that concept, then more or less you will pass. Okay? Because that's really the basic. Okay? For example, if you have a distillation column, what will happen to your distillate? That will come out, that will remain. It could be higher or lower. Something. If you have an idea already, oh my gosh, and then you will use that in the next stage, second stage, third stage. Then if you use that in the next stage wrong already, then you will be wrong entirely. Okay? That's the point. Okay? But here, this is not a distillation. Huh? It's only gas stoichiometry problems. Okay? Okay, people condensate, I don't like really condensate, and vapor, gano'n. Okay? But others also, chemical engineers, like that topic. It depends on the individual. Okay, somebody like this, somebody don't like that. Okay, like this. But in my case, I like the transport phenomena, the heat transfer. Okay, I like that so much. Especially the heat exchangers, ganun. Okay, I like the heat transfer through conduction, radiation, and convection. Okay, something like that. And also diffusion. I like diffusion. Okay, like that. I don't like screening, leaching, flotation, drying, crystallization. I don't like that. Okay, but I like this heat transfer really. I love it. Okay, I can relate in my day-to-day life. Heat transfer, in making coffee, something like that. When I cook my food, okay, when I get hot in myself, I have to cool myself. So that's heat transfer. It's very applicable in our day-to-day life, the heat transfer process. Okay, the transport phenomena, rather than to those drying, crystallization, burning, pyrolysis, catalytic cracking, ganon. Okay, what is polymerization, synthesis, esterification, okay, in organic chemistry or chemical processes. Okay, so going back, oh my gosh, ganun na lang siya. Times, going back to business na tayo ha, times temperature. Okay. What's the temperature of oxygen gas here given? 305.15. But actually, guys, the point something in the Kelvin is not really that relevant, huh? The 273.15. The 0.15 is not that really relevant. You can also delete that somewhere along the way in adding the temperature Celsius. Some books are deleting that. Some books are incorporating that. Okay, just like the same with the bar. The bar 1.0132 bachuchu bar is equal to 1 atmosphere. Also, books are deleting the 0.013 something, because it will not really achieve 101,325 Pascal or 1.25 kilopascal. Memorize all the units of pressure, okay? That's it. So that the questions cannot escape. If the problems have pressure, related problem, then you will answer it well. Okay? It cannot escape because you memorize all the pressure formula. Okay? So you're safe. Okay? Only to study and then problem. Okay? because there's a lot of pressure: dynamic pressure, static pressure, hydrostatic pressure. Okay, like that. So there's a lot of pressure: atmospheric pressure, vacuum pressure, absolute pressure, gauge pressure. Those types of pressures you have to understand. Okay, so that in it will come to the problems in the examination, then you can answer. Okay, because sometimes if you put only the gauge pressure and you will use the atmospheric pressure in your formula in the PV and RT, okay? Because sometimes it will be denoted as small letter G, PG, it's a gauge pressure. The vacuum is a PV, something like that. And then if you substitute that directly in the PV and RT, that's not the gauge pressure. There is the total atmospheric pressure. So you will become wrong automatically, something like that. Okay? Because you see, this pressure. If we are very wise, the author of the questionnaires are more than wise. Okay, they will really trick us for that. Okay, so that we will be confused. Charot. That's why they will regulate. Charot. Okay, what's the purpose of regulation if they didn't want to trick us? Okay, that's why Philippine Regulation Commission, they have to regulate how many will pass out of this total population, something like to gauge and calibrate the academic competence in terms of that professionalism, okay, something like that, okay, through their testing, okay. But it cannot be measured through that alone, the totality of an engineer. Just only one requirement. Okay? It's just only a piece of legality, but for the overall, that is not the basis. Okay, you get my point? It's because I have also look. Lorene Abilia is very intelligent. You know, Lorene Abilia. When I was in third year college, Lorene is fourth year college, and Lorene is very intelligent. His brother is top notcher in electrical engineering. Okay, top number one, some all over in the Philippines. Okay. Lorene also is intelligent, same as his brother. Okay, and then this Lorene Abilia, when finishing the chemical engineering, he did not take the examination. He proceeded directly to the masterals in chemistry in the University of San Carlos. And after graduating that, he teach, I think, chemistry subjects in Japan International University. It was offered by a certain like this, blah blah blah. So, and then she don't have time to take already the board examination. I think until now, because she enjoyed studying. Meaning to say, the license card and registration card of being chemical engineer is not that really important, especially if you proceed to teaching. You should have your master's and your PhD only. Okay, that's inter academe. But in terms of industry, some require, some not. Okay, that's subjective. It depends on the company. Okay, some require, some not. But in the Philippines, most of them required. Okay, because the chuba chucho, maarte kasi. Okay, something like that. But in the abroad, not really that an issue. Okay, but few also required, especially Saudi Aramco. Okay, Saudi Arabia, if you licensed engineer, you will not be prioritized. They will accept you as a short listing, but during the final, they will prefer those really because it's in their qualification. You must be at least licensed engineer, something like that. Saudi Aramco, and also Saudi Kayan, petrochemical project. But that doesn't mean that it's gonna be all the time like that. That's advantage for them. Okay, but not all will. You know already what I mean. Okay, it depends on the individual competence, blah blah blah, so and so, or the totality of the individual, something like that. Okay, so going back to the number of moles of oxygen, too much talking. 0.08206. Okay. My gosh. By the way, class, as I review my transcript of records, really, my chemistry are very high. Meaning to say, I really love chemistry. Really, last night, I scrutinized my grades. Okay, when I look at my grades, oh my gosh, my chemistry are very, especially organic chemistry. Okay, and the general chemistry lecture. But the other chuba chuchu, the unit operation, the unit processes, the are not very high, just in the average level, something like that. But my chemistry really is so high. Okay, that's why I plan to take PhD in chemistry, a master's in chemistry, and then PhD in chemistry. Okay, for that I have applied for that because I excels in chemistry. Okay, so if I will just continue my master's in environmental science, so I doubt I cannot manage more on the marine subjects, marine biology, because there's a lot of biology subjects in environmental science, really, the ecosystem, the ecology, the environmental. Though the environmental chemistry, I like that so much. The air quality management, I love that so much. Air quality, soil quality, and the water quality, I love that. That's chemistry, right? Soil chemistry, liquid chemistry, and air chemistry. But the topics of environmental science are, studying the diversity, the population, the geography, ganun. It looks like I'm not really that, what do you call this one? Convenient to study that one. So I really love chemistry. So I will shift to chemistry really. Okay. Or chemical engineering, master's in chemical engineering, but then doctor in chemical engineering. Okay, because when I was really in high school class, I really want to make my own book. Okay. That's my ambition when I was in high school. I want to make my own book authored by myself. Okay, something like that. Okay, and it was not come. Okay, true. Okay, never mind. Okay, so to the number of moles of oxygen gas. So 0.08206 times 305.15. Okay, so 15.88. Okay, like this. Okay, like that. 1.63 times 5.23. Okay, 8.5249. 8.5249. And then I come to think also, what is my research after that one? Because I need to have research thesis, a specific research thesis in my masteral, something like that. I need to specialize, I think so, polymer, like that, okay? Or what else? Polymerization. Like, I love polymerization, plastics, rubber, something like that, okay? So I need to find out really. Charot. Okay? Something like that. Because there's thesis for that also. 249. Then you have to defend, and you have to, validate your research. Literally, I want to become a scientist. Charot. 15.886. Okay. Scientist, it doesn't mean naman ko na ano lang siya nila. It doesn't mean like you have a study, a science study, then you have to undergo the research, you have to, get sample in the laboratory, and then you have to analyze that one. That's what we mean of a scientist. It's not only limited to the old scientists like Isaac Newton, like that. It's not like that. Okay? What I mean is we have our scientific research. Okay? Then if you have the scientific research, okay, that's why science, okay, from the word science, then a person that studies science and have an experiment and social science, that person automatically can be called a scientist. Okay, just like singer. Okay, if you sing, then you're a singer. If you dance, you're a dancer. Just like that. Okay, in English term, they're not referring to the action verb, something like that. Okay, so if you are, if you write, then you're a writer. If you report, you are a reporter. Something like that, ba? Okay, it doesn't mean to label that. If I want to become a scientist, will say I am Hamburg or whatever. No, it's not. It's really the terminology that matters for that. Okay, because I'm studying chemistry, something like that. So if you're studying chemistry, that's science. If you study biology, that's science. If you study physics, science. Then if you study that one and have a research for that, then after your scientific research and study, you will become a scientist. Got my point? That's it. Okay. So 8.5249. Okay. So divided by 15.886. So, 0.5366 siya, guys. Charot. 5.366 moles. Okay, we have the number of moles of oxygen, which is 1.366 moles, and we have the number of moles of ammonia, 0.2855 moles. Okay, guys. Now, we have our relationship in the stoichiometric relation here, and we have the number of moles also. Then take note, in here, class, there are number of moles in the chemical reaction, and we obtain also the number of moles through the equation of the PV and RT. Now, we need to have the relationship between the two. Okay, what gonna be the limiting reactant and what gonna be the excess reactant. Unsay di sobra, unsay kuwang, something like that in this reactant. You have to analyze so that your excess reactant will never be used because it's already excess. You don't need to use that one. That's why excess, right? So you need to use your limiting reactant. Okay, for this to solve for the volume of nitrogen gas at 37 degrees Celsius and 310.15 Kelvin and 1.52 atmosphere by using PV and RT again equation. Okay, now let's determine the limiting reactant and the excess reactant. Okay, so ammonia 0.2855 mole, just like a ratio proportion. Okay, ratio and proportion. 0.285855. Okay, moles. Okay, so your number of moles in the chemical reaction will be your denominator. So ammonia have 2 moles in the reaction man gyud siya. So over 2 moles. Then get the value. Cancel, cancel. So this is your fraction of the number of moles. It is our excess reactant or limiting reactant. So 0.2855 divided by 2, you have 0.14275. Okay, next. 0.14275. How about your oxygen class? Oxygen is here is 3 moles of oxygen. Sorry, it's in the second balance equation. This is first balance equation. Here, sorry. Final balance equation, not on the initial. Anyway, it's still also balance, but this fraction, we avoid the fraction of good. Okay? Like this. So 0.285 divided by 4 siya. Sorry. Okay. But I think it's all produced the same answer, right? Because it's already balanced man good siya. Okay. But let's just use the not fraction. Okay, 0.2855 divided by 4. So you have 0.071. Your ammonia, the fraction of the number of moles over the number of moles in a chemical reaction. Okay, and you have the number of moles of oxygen. Again, the same story. You need to compare and a fraction for that. Okay, so moles of oxygen here we have 366 as yun yung numerator, 3 moles of oxygen in chemical reaction here. Okay, ganon. So pila siya. Chart. Okay, so 0.5366 0.5366 divided by ganon siya, 3. 0.178 is higher. 0.788 or 0.0 this one. So this is higher, meaning this is in excess. Okay. This here, excess. There's an excess, and it's a greater amount. And this is only limiting. This is very open something lang siya. So we need to use the limiting reactant, this one. This is the ammonia is our limiting reactant. Sometimes also in the problem, the explanation, particularly for examination. Okay. You need to find out really the excess reactant, the definition of the limiting reactant, something like that. What is that all about? Ganon. To compute for the volume of the nitrogen gas, the problem. Actually, there's only one problem in gas. PV is equals to nRT, then compute for the volume of nitrogen gas. Element. That's the technique here. Okay, so Nitrogen, nitrogen all. Oxygen, oxygen all. Like that, blah, blah, blah. So, okay. So pressure, our temperature, 310.15. And then bingo, it was 1.52 divided by 25.45. Ilan man siya? Okay. 310.5 times 0.806 25.47. Okay, 1.52 yung will be in our PRP. Okay. So here. Okay. So up here because promptly my brain cells that, oh my gosh, there's something missing, something like that. Okay. Never do it, and you can only get few out of 100 questions. Okay. So the technique is only review twice, not thrice. For then, if you don't know the answer, confused, then jump to other questions to save time. Maybe the other questions are very it will take time. This is only, but what if in the actual examination? Okay. And then over pressure. Pressure is 1.52 then. So very dirty. See, as you can see, very dirty, right? So 14275 39 letters is the volume of nitrogen to kulbaan ko. Okay. Okay. Because I did not solve this in advance. Let's see, Bachelor of Mechanical Engineering, November 2004 examination. Okay, B, 2.39 liters. Imagine that one question only. Okay, for right, but I make it slow, that's why. Okay, because of the formula, how you present the unit, a little advantage to get and obtain the correct answer rather than get a A and then you're panic that and your heart beats fast to take the exam, something like that. There's a pressure. Pressure is also force over area. Then if there's a lot of pressure, expect more force.